this is an introduction to our musical laser transmitter and receiving circuit for ECE 2001. All right, to begin, this is the musical laser transmitter. It consists of a summing circuit, which is right here, and I'll go on further to discuss that in detail, that ultimately amplifies a signal or two that are added together and outputs it through a laser diode. So to begin, it's essential for our circuit to have this voltage divider down here. This divides our voltage from 9 volts to 4.5 volts at this node. It goes through this operational amplifier, which will set this voltage and output it right here so we can actually use it. Once it's out here, the voltage above and below this voltage divider are fixed, and adding other elements will not change that. This is essential. Over here, we have the same thing. We included it on our board twice to make it easier for us to use. There's really no difference between these two, and they could be done with just one. So going up here, this is our mic circuit. The mic is grounded on one end, and the signal from someone's voice will go in and generate an AC current with an offset of about 4.5 due to this reference resistor. That offset will come through the capacitor and then go through a potentiometer and through another capacitor, and then that will be summed with our MP3 signal, which is going through the same series of steps. Once that is summed through there, it comes in here, and the reference or the gain will be determined by this resistor divided by this resistor for each one. Once that comes through, it's powered by 9 volts and 0 volts. It will be amplified, so we will have a large signal, and that will go through this resistor to limit the current and then pass our signal through the laser diode.
So this is the receiving circuit part of our musical laser. Basically, down here, we have the same voltage divider we just talked about on the transmitting circuit. So basically, our signal is coming in here to a solar cell. It goes through a capacitor to filter out the DC, so it's centered around 0 volts. This resistor right here, it's going to be a big resistance because you want little current flowing through it, so that most of our signal is forced through the op amp. These two determine the gain right here. You divide this resistor by this resistor to determine your gain. And then it's powered by 0 and 9 volts here. This is set to 4.5, as we said in the transmitting circuit, so that it will be centered around that. And then you basically have the signal come through the op amp and out the other side, and you get music out.
All right, so this is our circuit. Briefly going to go over parts of the schematic that were on here. This is one of the voltage dividers. The other one is using the bottom corner of this op amp. Our AC signal from our iPod will come in through here. From the mic, it comes in through here. They add up at this node, go through this operational amplifier, come down this yellow wire with the output, and they will go through this and then out our laser. Over here, the laser will strike our solar cell. It'll produce an AC current that will go through this capacitor, come through this resistor, go through this speaker eventually, and it'll all be stepped up by this voltage divider and amplified by that amplifier. With that said, let's rock on. All right. We also noticed that the voltage is not very, or the signal is not very loud out of this amplifier, and it has a lot of noise. To get rid of some of the noise, but it dimmens the sound, you can put this capacitor from the output to the input on this nose, and it will eliminate the noise, but it takes away some of the volume. Very clear on a loud computer speaker, though.